So today we're going to discuss the last subtopic for chapter 2, so which is topic 2.6, known as the inverse functions. So inverse function is something that you have seen before. It's nothing new. So either you have seen this during additional maths, I think it's form 4, or you should have seen this during your elementary study before this, whether it's diploma or whether it's matrix or whether it's form 6. This is something that you should have seen before. Okay, the first characteristic of inverse function is that it can only exist for one-to-one function. If the function is not one-to-one, then automatically, so the inverse does not exist. For example, so let's say this is going to be my function. I have a function of f of x equal x squared. Okay, let's say I have two domain values. The first one is 2 and the other one is -2. So when I substitute into the function, f of 2 is going to equal 2 square. That is going to equal 4. And even when I have f of -2, I will end up with -2 square, which is also equal 4 basically. So these two numbers are going to be mapped to the same value, which is going to be 4. So this relationship over here, so this is not a one-to-one function. So this is called as being a many-to-one function. Okay, so what happens is that when you have the case of many to one, so does the inverse exist? No, so the inverse does not exist. For the case of quadratic function, f of x equal x squared, so the inverse does not exist because this is a many to one function. It is not one to one. So basically inverse is strictly only for one to one, right? So how do we verify? If the question asks you to, the question say verify that the following f inverse is going to be at the inverse for f function. So this is how the verification is done. Verification means verify means proof. So proof that f inverse f is the inverse of f. So this is what you have to do. So you have to do a composite function, and you have to show that when you have f inverse f of x or f of f inverse x, so both of them are going to give you a function of x. Okay, so either way, so you have to do one of them. You don't have to do both of this, just one of them. So you're going to do a composite function, so whether the inverse at the back or whether the inverse is going to be put into the other function, so that is going to be totally up to you. You can use either one of this function. Okay, and how do we identify? So if you are given a function, a graph, so how do you identify whether the function has inverse or not? So that can be done through the horizontal line test. So the horizontal line test is going to give you an idea, so whether inverse exists or not. So whether inverse exists. So we have actually come across the other line test, so which is known as the vertical line test. So what is the difference between a vertical line test and horizontal line test? So we use vertical line test when we want to test whether a given graph is a function or not. Okay, remember, so vertical line test, so whether it's a function or not. Horizontal, whether the inverse exists or does not exist. So what you're going to do is you're going to draw horizontal line, and if the horizontal line cuts at more than one point on the graph, automatically the inverse does not exist. So here I have two graphs. Let me call this as number 1, and this is going to be our number 2. So have a look at their second line over here, second line from the top. So when I draw the line, it actually cuts at multiple points. So here, this is the first point, second point, third point. So what happened is that is why this is not a one-to-one function. So inverse does not exist. So let me put over here. So inverse does not exist because it's not a one-to-one function. This one on the other hand, so no matter where I put the horizontal line test, it never cuts at more than one point. So therefore for this case, so the function is one-to-one, and yes, the inverse exists. So this is called as the horizontal line test. So what you have to do is you draw horizontal lines and make sure that the line only cuts your graph at exactly one point every single time, no matter where the horizontal line test is. And next we're going to have a look at domain and range. So we have seen this before. What is domain and range? So domain actually represent the value of x that is possible, and range represent the value of y that is possible. Okay, what happens is that when you have f and f inverse, the domain is going to be interchange. For the case of f, the domain is now going to be the range of the inverse. The range of the original function is going to be the domain of the inverse. Okay, let me show you an example. Okay, let's suppose I have a square root function. So f of x equal x minus 1. So let's find the domain and range for this one. You know that for the case of square root, so there's a requirement that whatever function that goes inside the square root, it must be greater than or equal 0. Or else it's going to be undefined. So what happens is that x must be greater than or equal 1. So therefore what happens is that our domain, so let me put this, that this is going to be domain for f of x. For f of x, so the domain is going to be from 1 until infinity. So it could be any value from 1 until infinity for value of x. And what happened to the range? We know that f of x is actually equal y. And for the case of square root, so y must be a positive value and at least it should be a 0. So for this case, what happens is that range must be from 0 until infinity. So that is going to be our domain and also our range. Okay, so what happened is that, let's suppose now we're going to find the domain and range for f inverse of x. So now it's going to be interchange. So what do I mean by interchange? So the range for the f of x is now going to be the domain for the inverse. So for the inverse, the domain is going to be from 0 until infinity. And whatever that is the domain for the f of x is now going to be the range for the inverse. So which is going to be from 1 until infinity. So that is how it goes. Remember, even though we don't know what is going to be the function of an f inverse, even if we don't find it, we don't really have to. We can tell the domain and range from what we have from f of x. Okay, it's going to be the opposite for them. Okay, what else do we have here? So yeah, that's what happens. So domain and range is going to be interchange for the case of f and also f inverse. Okay, so now this is going to be the graph of inverse function. So the graph of f inverse is the reflection of the graph of f. So f inverse is the reflection of the graph of f on the line y equal x. So what does that mean? Okay, let me show you what does that mean. Okay, let me start with the axis first. So let's suppose this is going to be my axis and I have a graph of f of x equal x cubed. So graph f of x equal x cubed is going to look like this. This is a graph of f of x equal x cubed. So let me draw that prettier. Okay, so that's roughly how it's going to look like. And let's suppose now, so what I'm going to do is I'm going to sketch a graph of y equal x. So how does my graph y equal x looks like? Let's say it's going to be something like this. So this is going to be graph of y equal x. And let me highlight this with the highlighter so you can see clearly where it is. So this red line is actually my graph y equal x. So what I'm going to do is I'm going to treat like y equal x is actually a mirror. So that is going to be my mirror. So this is going to be a graph of f of x. Okay, if I want to sketch the graph of f inverse, what I have to do is I have to reflect the function f of x on the y equal x. So this bit over here, so I'm going to start with this bit. When I reflect that, I'm going to have this line. So this is going to be the line. Okay, and this bit right here, so the second part, let me call that as the second part. So when I reflect that on the y equal x, so my graph is going to look like this. And then the third part is going to look like this. And the last part is going to be that line. Okay, so the one in blue, so that is my graph f of x. The one in green, that is the graph of f inverse of x. All you have to do is reflect that on the y equal x function. Okay, so that is how it's done. So this is what happened over here as well. It's pretty much the same idea. So all you have to do is sketch a line of y equal x and then start reflecting. Okay, how do we find the inverse function? So this is going to be the steps. So the first step, what you have to do is you are going to replace f of x with y. And after that, you're going to solve for x. What does it means by solving for x? Means that you have to find only x on the left hand side of the equation. So make it in terms of x. So x is going to be the subject of your equation. And after that, so you're going to interchange x and also y. So this is going to be the last step. And I'm going to demonstrate by using these 3 examples right here. I'm pretty sure that you have already known this, as I mentioned to you before. So if you already know this already, no need to have a look at all my examples. You can do it with me, in fact, or you can just simply do this on your own and check whatever that you get, whether we matched. Okay, so I'm going to start with A. So the function is given by, so f of x equal 3x plus 2. So the first step is I'm going to replace the f of x by y. I'm going to write y is going to equal 3x plus 2. That is step number 1. So I'm put over here because this is the first example. So this is going to be step number 1. Okay, now step number 2. I'm going to rearrange this equation and I'm going to find what is my function in terms of x. X is going to equal what? So now I'm going to rearrange them. I'm going to write that 3x is going to equal y minus 2 and x is going to equal y minus 2 over 3. So that is going to be step number 2. And step number 3, what I'm going to do is I'm going to make the function, so this I'm going to interchange the position of x and also y. Okay, so I'm going to make this whole thing on the right hand side. So this should be in terms of x. So I'm going to write that f inverse of x. So now all I have to do is replace the y by x. So it's going to equal x minus 2 over 3. So that will be step number 3. That's it. Okay, and let me change the color of this. It should have been in this blue. Okay, that is going to be our first example. So let me show you the second example for B. So I have a square root function. So square root of x minus 2. So I'm going to write that y is going to equal square root of x minus 2. So how do I get rid of the square root? I'm going to square both sides of the equation, for which I'll end up with y squared is going to equal x minus 2. And my x is going to equal y squared plus 2. Okay, and then remember all you have to do is you're going to replace the y on the right hand side by x. So therefore my f inverse of x is going to equal x squared plus 2. So I just changed the y to x. That is going to be for B. And the last example, C. So let's see what kind of function do we have. For C, we have a function of 4x over 2 minus x. So I'm going to write that. Y is going to equal 4x over 2 minus x. Okay, this one is the level of complexity is going to be slightly more complicated than the previous two, because the previous two example, I only have 1x on the right hand side of the equation, 1x and 1x. But this one, instead of having only 1x, I have 2x. So in the fraction, I have 1 at the top and 1 at the bottom. So now what I'm going to do is I'm going to rearrange them. I'm going to bring that up. I'm going to write that y multiplied by 2 minus x, that is going to equal 4x. And when I expand, I will get 2y minus xy, that is going to equal 4x. So what I'm going to do next is whatever terms that are related to x, I'm going to put them together and factorize them. So therefore, I'll end up with 4x plus xy, that is going to equal 2y. And now let's start factorizing. I'll end up with x multiplied by 4 plus y, that is going to equal 2y. So x is going to equal 2y over 4 plus y. And now we are almost done. So I can write that my function f inverse of x is going to equal 2x over 4 plus x. And now because we have two terms with y, so both of them are going to be replaced in terms of x. So that is going to be the inverse function. Okay, so the idea is very simple, and I'm pretty sure that this is nothing new to you. So what I would like you to do next is to try to do this exercise, and there's more exercise that I actually combine 2.5 and 2.6 as well. All right, so have a go at them, and if you have any problem, feel free to ask.